Let's tackle the next topic in 4.3. The second method for finding the greatest common divisor or factor is the prime factorization method. I'll do two examples for you. So the first example of prime factorization method is between the numbers 420 and 63. This is the way the question will be written. The greatest common divisor between 420 and 63. Prime factorization means you have two choices, and I like the factor tree method, so we're going to use a factor tree to find the prime factorizations of 420 and the prime factorization of 63. Break 420 into two factors. 10 times 42 comes to mind. There's many other factors, I just needed two of them. 10 times 42. Well, I know 10 can be broken down into 5 times 2. But 2 can't be broken down anymore. There's no factors besides 2 times 1. 5 can't be broken down anymore. Its only factors are 1 and 5 because they're prime numbers. But 42 can be broken down into 6 times 7, and 6 can be further broken down. 7 cannot, it's prime. The answer to the prime factorization of 420 is all these numbers at the end. 2 times 2 times 3 times 5 times 7. 2 times 2 times 3 times 5 times 7. Multiply that together, you'll get 420. Don't use the 6 because you further broke it down. Likewise, don't use the 42 or 10, you broke them down some more. Only use the prime numbers at the very tips of the branches. Let's break 63 down using a factor tree. 9 times 7 is 63. 7 can't be broken down anymore, it's prime, but 9 is 3 times 3, and now we're at the ends of all the branches. All those numbers are prime numbers, and that's the prime factorization of 63. 3 times 3 times 7. 3 times 3 times 7. Now we have our information. We just need to find the greatest common divisor or factor. What's the greatest common divisor between the two? Yes, they both have a 7, but they also both have a 3. Not 2 3s, only he has that, but they both have a 3. That's the greatest common divisor, the 3 and the 7. 21 is the greatest common divisor between 420 and 63. Let's do another example. That's what I just did. Let's find the greatest common divisor between 140 and 175. Prime factorization means find all the prime factors of 140 and 175 and find the ones they have in common. I'm going to find the factors, prime factors of 140 and then the prime factors of 175. I know 140 is divisible by 10, so I'm going to write 10 times 14. Could have written 2 times 70. It'll still work out. Then you break the 10 down further, break the 14 down further, and you're at the ends of all the branches. You cannot break these numbers down further because they're all prime, and you don't need these because they got broken down. So the prime factorization of 140 is what we've circled. 2 times 2 times 5 times 7. I'm just putting them in order. 2 times 2 times 5 times 7. Let's break down 175. I know it ends in a 5, so 5 must be a factor. 5 divided into 175 goes 35 times. 35 can be broken down some more. And now the numbers at the end of the branches are our prime factors. They can't be broken down anymore. So the prime factorization of 175 is 5 times 5 times 7. To find the greatest common factor, we need to see what they have in common. They have a 7 in common, and they have 1 5 in common. We can't say 5 squared because this number doesn't have 5 squared. So So the greatest common factor between 140 and 175 is 5 times 7, 35.